China is building machines so massive, so powerful, that engineers around the world are asking one question: how? From the LINGHANG TBM to the bucket wheel excavator, these are 15 mega machines that just broke every law of physics. LINGHANG TBM, a machine longer than a football field, heavier than 8.8 million pounds, carving through rock nearly 300 feet beneath a river. That's the LINGHANG. This is the world's largest diameter high-speed railway tunnel boring machine. The cutting wheel alone measures 50.5 feet across. The entire machine stretches 485 feet long and weighs roughly 4,000 metric tons, and it just completed over 6.2 miles of continuous tunneling beneath the Yangtze River, a global first for any machine this size. The LINGHANG is building the Chongming-Taizhou Tunnel, connecting Shanghai's Chongming Island to Jiangsu Province. Once finished, high-speed trains will blast through at 217 miles per hour, the fastest design speed for any underwater tunnel on Earth. The deepest section sits 292 feet below the riverbed. The brain behind this beast is fully autonomous. An advanced smart control system adjusts pressure, predicts geological conditions, and guides the machine forward using hundreds of historical datasets and machine learning models. This technology set a world record by tunneling 2,356 feet in a single month. Back in 2017, China unveiled its first domestically built 50-foot class tunnel boring machine, ending foreign dominance in this category. Today, Chinese-made TBMs control nearly 70% of the global market. Bucket wheel excavator. Some machines dig holes. This one devours entire mountains. The bucket wheel excavator stands taller than a 30-story building, stretches longer than 2 football fields, and never stops feeding. These mechanical giants are among the largest land vehicles ever built. China operates several of these giants in massive lignite mining operations across Inner Mongolia and Xinjiang. Chinese deployed bucket wheel excavators stand over 295 feet tall, stretch more than 656 feet long, and weigh thousands of tons. A massive rotating wheel studded with buckets continuously scoops material as it spins. Each bucket can hold over 530 cubic feet of earth. The wheel itself measures up to 69 feet in diameter, roughly the height of a 7-story building. Material travels along conveyor belts and gets deposited elsewhere, creating a non-stop mining operation. The numbers are mind-blowing. A single bucket wheel excavator can move 314,000 cubic yards of overburden daily. Peak operations have recorded 497,000 cubic yards in a single day. That's enough earth to fill 150 Olympic swimming pools every 24 hours. China has deployed these behemoths in massive lignite mining operations, stripping away soft rock without blasting. Modern versions feature GPS tracking, automated systems, and online monitoring that let operators control crucial functions remotely. These machines operate in extreme conditions, temperatures as low as -49 degrees Fahrenheit. 18 crawler units propel them forward, cutting swaths over 590 feet wide. Mengjiang Deep-Sea Drilling Vessel. China commissioned this vessel in Guangzhou on November 17, 2024. The mission: drill 6.8 miles beneath the ocean floor and reach the Mohorovichich discontinuity, the boundary between Earth's crust and mantle where humans have yet to venture. The Mengjiang stretches 590 feet long with a 108-foot beam and displaces 46,958 tons, making it China's largest scientific research vessel. Range extends 15,000 nautical miles. The ship sustains 180 crew members for 120 days without resupply. It meets Super Typhoon safety standards and operates in any waters on Earth. The drilling system achieves several world firsts. The hydraulic lifting rig handles both oil exploration and scientific core sampling with a top drive capacity of 1,000 tons. 4 drilling modes and 3 coring methods cover every operational need from deep-sea resource exploration to geological research. 9 advanced laboratories fill the vessel, covering geology, geochemistry, microbiology, ocean science, and drilling technology. An automated core sample storage system, another world first, preserves specimens for analysis. The core samples this vessel retrieves will provide direct evidence for studying plate tectonics, oceanic crust evolution, ancient climates, and the origins of life itself. The Mengjiang represents humanity's first serious attempt to pierce the planet's deepest secrets. Iron Monster. The SLJ 932 is a bridge-building giant designed by the Shijiazhuang Railway Design Institute and manufactured by Beijing Huaojoint Machinery Company. Stretching over 300 feet long and standing nearly 30 feet tall, this beast constructs high-speed rail bridges at a pace that stunned engineers worldwide. Here's how it works. The Iron Monster picks up a prefabricated concrete bridge section weighing up to 1,000 tons, carries it beneath its massive frame, and places it directly onto support pillars. Then it rolls forward over the section it just installed and repeats the process. Span after span, the bridge grows behind it. The mobility system is equally remarkable. 64 wheels divided into 4 groups of 16 power this giant. Each group rotates a full 90 degrees, allowing the machine to move sideways with precision. Loaded with a bridge segment, it cruises at 3 miles per hour. Empty, it reaches 5 miles per hour. Traditional bridge construction requires cranes, scaffolding, and weeks of setup. The Iron Monster eliminates all of that. One machine handles lifting, carrying, and placing in a single continuous operation. Each unit completes between 700 and 1,000 bridge spans before retirement. Across China, these machines helped build over 31,000 miles of high-speed rail network faster than anyone predicted. Tyson Gantry Crane. Lifting 44 million pounds in a single move sounds like science fiction. The Tyson Gantry Crane made it a reality. Standing at Yantai Raffles Shipyard in Shandong Province, this mega crane holds the Guinness World Record for the heaviest weight ever lifted. The record-breaking moment came when Tyson hoisted a water-ballasted barge weighing 46 tons, roughly the weight of 150 Boeing 747 aircraft combined. Dalian Huarui Heavy Industry designed this giant for offshore vessel construction. Semi-submersible drilling platforms and floating production storage units need massive deck sections placed onto their hulls with precision. Before Tyson, shipyards assembled these vessels using smaller lifts of 1,100 to 2,200 tons per module. That meant endless hours of work at dangerous heights. Tyson flipped that approach. Complete 22,000-ton modules now rise from the ground and land directly onto vessel hulls in single operations. Project schedules shortened significantly. Shipyards reported manpower savings reaching 2 million man-hours per vessel. The specifications match the ambition. Tyson towers 436 feet high with a span of 394 feet. The wire rope system stretches an incredible 31 miles in total length. Maximum lift height reaches 262 feet. The dry dock beneath measures 1,247 feet long. The Honghai crane eventually pushed lift capacity to 24,250 tons in 2014. But Tyson pioneered the mega lift revolution that transformed how the world builds offshore platforms. XCMG XGC 8000 Crawler Crane. Installing a wind turbine the height of a 50-story building requires a crane that defies conventional limits. The XCMG XGC 8000 is that crane. This is the world's first 4,000-ton crawler crane, fully designed and manufactured in China with independent intellectual property. The boom stretches 709 feet long. Maximum lifting torque hits 88,000 ton-meters. And in August 2024, this machine installed the world's largest 26-megawatt offshore wind turbine in Shandong Province. The turbine itself is a monster. Over 3,000 components, a hub center standing 607 feet above ground, a rotor sweep area covering 828,000 square feet. The XGC 8000 lifted the 2.2 million-pound nacelle and aligned over 200 bolts with millimeter-level precision at extreme heights. The challenges went beyond weight. Soft tidal flat foundations and cramped workspaces required innovative solutions. Engineers reinforced the ground with advanced piling techniques and deployed integrated systems for aerial coordination. The nacelle landed exactly where it needed to be. Once operational, that single turbine generates 100 million kilowatt-hours annually, enough electricity to power 55,000 households for a full year. Since its debut in 2013, the XGC 8000 has completed over 20 major projects across China, Saudi Arabia, and Oman. Cumulative lifting totals exceed 440 million pounds. The crane holds 3 world-first technologies, 6 internationally leading innovations, and more than 80 national patents. CYP 500 Track Laying Machine. Laying railway tracks by hand takes weeks. The CYP 500 does it in hours. This track-laying machine made its Southeast Asian debut on the China-Laos Railway project, installing a 1640-foot steel track section in Vientiane. That single segment became the longest steel rail outside of China in all of Asia. The CYP500 operates like a moving factory. It picks up prefabricated rail sections, positions them with precision, and secures them to the ground in one continuous workflow. The machine runs 24 hours a day, laying up to 1.24 miles of track daily. On the China-Laos project, it consistently met the demanding schedule of nearly 1 mile per day. The railway itself stretches 257 miles, linking the Mohanbotan border gate in northern Laos to the capital Vientiane. Trains will operate at speeds reaching 99 miles per hour once the line opens. For a landlocked country like Laos, this connection transforms geography entirely, turning isolation into accessibility. Construction demanded years of preparation. From 2016 to 2019, crews completed bridges and tunnels across challenging terrain. The second longest tunnel on the project stretched over 15,000 feet through sparsely inhabited territory. The CYP500 arrived to finish the job by laying the final track sections. This machine represents the Belt and Road Initiative in action, one rail section at a time, connections spread across Southeast Asia. Zoomlion Tower Crane. Lifting 1.5 million pounds to the height of a 130-story building sounds impossible. The Zoomlion R20720 does it routinely. This is the world's largest tower crane. Maximum lifting capacity reaches 794 tons. The boom extends 12 feet outward. And right now, this machine is constructing the Shijiang Bridge in Guangzhou, which will become the world's largest dual-level suspension bridge with a main span of 752 feet. The engineering behind this crane required breakthrough innovation. Weld seams stretch over 304 miles throughout the structure. Individual components weigh up to 102 tons. The machine integrates 158 research achievements and holds 305 invention patents. Revolutionary counterweight technology sets this crane apart. The system moves precisely in response to changing load moments, boosting lifting performance by over 60%. A high-load lightweight design reduces the upper structure weight by 20% compared to conventional cranes, solving transportation and assembly challenges that plague ultra-large equipment. The ETI Intelligent Control System runs the operation with millisecond response times. Operators execute quick, precise movements even under extreme conditions like strong winds, high humidity, and heavy loads. Before the Shijiang Bridge, the R20720 helped construct the Ma-Anshan Yangtze River Railroad Bridge, the world's first three-tower cable-stayed bridge with dual main spans exceeding 32.80 feet. Sony 86 meters, Pump King. When Sany Heavy Industry unveiled its 86-meter truck-mounted concrete pump in September 2011, the construction world took notice. This colossal machine earned its Pump King nickname by shattering records and redefining what engineers thought possible in concrete pumping technology. Standing tall enough to reach a 25-story building, the Sany 86 meters features an innovative 7-section boom design, a pioneering achievement in the industry. This massive arm rides atop a 9-axle all-terrain chassis with 5 steering modes and a remarkably tight 49-foot turning radius, allowing this giant to navigate surprisingly compact job sites. What truly sets this machine apart is its revolutionary steel. Sany invested over 3 years and conducted more than 1,000 tests to develop the 26 1,000 per square inch super-strength steel used throughout the boom. This breakthrough allowed engineers to create an extraordinarily long yet stable arm without excessive weight. The 86 meters' real-world capabilities proved invaluable during a critical moment in history. During the 2011 Fukushima nuclear disaster in Japan, this technology became essential. Japan's domestic pump trucks topped out at 164 feet, but they needed at least 184 feet to safely deliver cooling water to the damaged reactors. Chinese-made long boom pumps stepped up when the world needed them most. With specifications including a 314 cubic yard pump capacity, the Sany 86 meters represents more than impressive numbers. It embodies human ingenuity pushing boundaries. Kunlun Transport Erect Machine. Developed by China Railway Construction Corporation, Kunlun is the world's first transport erect machine capable of handling 1,000-ton box girders. Traditional machines could only manage one girder size. Kunlun handles 3, spanning 79, 105, and 131 feet, doing the work of 3 machines in one. This beast can climb 30-degree slopes and navigate tight curve tracks that would stop conventional equipment dead. The secret lies in its aerospace-grade materials, the same lightweight, high-strength composites used in aircraft and submarines. The machine's brain is equally impressive. Intelligent systems automatically transport girders through tunnels and position them with millimeter accuracy. Real-time data feeds directly to railway management centers, letting operators monitor every movement remotely. Kunlun just completed heavy-duty testing and is now building the Meizhou Bay Bridge, part of China's first cross-sea high-speed railway connecting Fuzhou to Xiamen. The 131-foot girders it places reduce train resonance, enabling stable operation at 249 miles per hour. The numbers speak for themselves. 20% lower construction costs, 25% faster erection speed, smaller construction footprint for easier navigation. Sunward Rotary Drilling Rig. This super rotary drilling rig was purpose-built for one of China's most challenging engineering projects, the Shihumen Railcom Road Bridge, the world's largest combined highway and railway bridge spanning 10,230 feet. It drills 20.7-foot diameter boreholes, a world record for rotary excavation piles. Each pile plunges 276 feet deep through brutal geology, including 75 feet of weakly weathered rhyolite and 25 feet of slightly weathered rhyolite. This is rock that destroys ordinary equipment. The construction environment was equally punishing. Strong winds, massive waves, water depths exceeding 197 feet, rapid currents, and multiple typhoons during drilling operations. The SWDM 1280 conquered them all. Development took 2 years of intensive research. Sunward's team held 12 expert technical workshops before the machine rolled off production lines in January 2022. They solved critical challenges including construction stability for oversized equipment, transportation logistics, and machining precision for super-large components. The results speak volumes. In under 1 year, the SWDM 1280 completed all ultra-large diameter deep-sea piles for the bridge, finishing well ahead of schedule. This machine fills a critical gap in China's construction capabilities, proving that even the most extreme underwater foundations are now within reach. Hydraulic excavator. The XCMG XE7000 is a 700-ton mining beast that puts China on an elite global map. When it rolled off the production line in 2018, China became only the 4th country capable of building excavators this massive, joining Japan, Germany, and France. This machine doesn't just dig, it devours. The bucket alone swallows 60 tons per scoop, nearly matching a full train car's capacity. Operating at Haidaigu, one of Asia's largest open-pit coal mines in Inner Mongolia, the XE7000 moves over 1960 cubic yards of material every hour. That's 18 hours a day with over 90% availability. The first unit logged nearly 13,000 hours of real mine experience. XCMG absorbed every lesson learned and built an upgraded second excavator with comprehensive improvements. The new design features a larger backhoe bucket, enhanced heat dissipation preventing overheating during continuous operation, and intelligent lubrication management that automatically adjusts grease distribution for maximum reliability. Operator comfort got serious attention too. Non-slip walkways reach every maintenance area. The platform layout is more user-friendly. Safety and convenience finally meet brute force. Mine managers rave about its flexibility compared to electric shovels and its sensitive manipulator controls. XCMG service teams stay stationed at mines year-round. Chief Hypergravity Centrifuge. Buried 49 feet beneath Zhejiang University's campus in Hangzhou sits the Centrifugal Hypergravity and Interdisciplinary Experiment Facility, CHIEF. Its centerpiece, CHIEF 1300, became the world's most powerful research centrifuge when it came online in September 2025. The even more powerful CHIEF 1900 arrived in December 2025 for installation, ready to shatter that record. A giant arm with a 21-foot radius spins at extreme speeds inside a 2,500 square foot underground chamber. When fully operational, CHIEF 1900 generates forces up to 1,900 times Earth's gravity, crushing the previous record held by the U.S. Army Corps of Engineers facility in Mississippi. For comparison, a roller coaster hits about 2G. Astronauts during launch experience around 5G. Your washing machine rarely exceeds 2G during its spin cycle. CHIEF operates at nearly 1,000 times that intensity. The practical applications defy belief. Want to test a 984-foot dam's structural integrity? Build a 10-foot model and spin it at 100G. The stress levels match exactly. Need to study how pollutants travel through soil over a century? CHIEF compresses that journey into just 3.65 days. Scientists can recreate earthquakes, dam failures, and tsunamis inside a laboratory. The $285 million facility features 3 centrifuges, 18 in-flight devices, and 6 experimental cabins. Vacuum and wall cooling systems prevent overheating during sustained runs. Early experiments have already validated hydropower dam foundations against earthquakes, modeled tsunami effects for offshore wind farm placement, and synthesized advanced metal alloys with unprecedented strength. China dethroned America's long-standing record holder and opened the facility to researchers worldwide. Blue Whale 2 Semi-Submersible Drilling Rig. China's homemade ultra-deep-water semi-submersible drilling rig stands as tall as a 37-story building. Its deck spans the size of a soccer field, but the real magic lies beneath the surface. Blue Whale 2 can drill to an astonishing 50,000 feet, the deepest drilling capability of any rig on the planet. Developed by China Yantai CIMC Raffles Offshore, this beast isn't just powerful, it's nearly indestructible. The platform withstands winds up to 112 miles per hour, allowing operations in seas that would cripple ordinary rigs. It completed sea trials in August 2017 and set sail from Yantai in Shandong Province. Blue Whale 2 follows its legendary sister rig, Blue Whale 1, which made history in the South China Sea. From May to July 2017, Blue Whale 1 conducted China's first successful extraction of gas hydrate, commonly called combustible ice. This frozen fuel forms under extreme pressure in deep-sea permafrost. 1 cubic meter releases approximately 160 cubic meters of natural gas while producing half the carbon emissions of oil or coal. The successful mining marked a massive leap toward replacing conventional fossil fuels with cleaner alternatives. If you enjoyed this video, please like, subscribe, and comment on which aspect shocked you the most.